Parabola Notes, Part 1. Let's start with the definition of a parabola and then look at what that definition means. The set of all points for which the distance to the focus equals the distance to the directrix. So I want you to notice on the picture here, the point 0p here, that's the focus. The line y equals negative p, that is the directrix. So we have a fixed point and a fixed line, and those two are essential for constructing a parabola. So let's look at an animation that will help us see what we do with a parabola and how it's constructed. So just focus here. You'll see a lot of different conic sections, but I want to focus on what happens with the parabola. So look at the parabola here. Now notice I have a point here that the distance from the point to the focus and the point to the directrix is equal. And always notice that the distance to the directrix is a perpendicular line. So let me erase that and let's animate this. So if I move this point along here, notice that the distance to the focus and the distance to the directrix remains the same. It's always equal. And when I draw that, I end up with a parabola. The focus being in the center and the directrix perpendicular to the axis of symmetry here and sitting outside the parabola. So if we look here, there's a picture. We could draw this on our graph. So if we have a point here, we'll call this point P at xy. And if we go from the focus 0p to the point xy, that distance is equal to the distance from the point P perpendicularly down to the directrix. So these two distances are always equal, and if we swung that point around, you'd see that those two distances always staying the same. Now because they're the same, we can use the distance formula to equate those distances, and we come up with the definition, the algebraic definition of the parabola. So let's label our third point. We have one point that's 0p, another point that's xy, and then this third point, notice, is directly below xy, so it has the same x coordinate, which we'll call x, but its y coordinate is now negative p. And notice that means that the distance from the center, which is at 0, or the vertex, which is at 0, 0, to P is a distance P, and then from the vertex down to the directrix is also the same distance. So we can take the distance from the focus to P and from P to the directrix, and we can equate those using the distance formula. So I can say, using the point P to the focus, that x minus 0, subtracting the x coordinates, squared plus y minus p squared, that would describe this distance right here from the focus to the point. And then we can say x minus x squared and y minus a negative p squared. So that equals x minus x squared, y minus a negative p squared. Now I'm going to simplify this and make it look a little nicer. So distance from point to focus equals distance from point to directrix. Square both sides. That gets rid of the square roots. And then let's simplify what's inside the squared term. So we have x minus 0 squared simplifies to x squared. Y minus p squared, we're going to expand that to y squared minus 2py plus p squared. We have x minus x squared, which is 0. And then we have y minus a negative p, that becomes y plus p. So we have y squared plus 2py plus p squared. Now notice that we have a y squared and a p squared on both sides of the equation, so we can just subtract that from both sides, and we end up with x squared minus 2py equals 2py. And if we add 2py to both sides, we have x squared is equal to 4py. That is the basic form of a parabola that opens in the y direction. So it either opens up or down. If 4p is greater than 0, it opens up. If 4p is less than 0, it opens down. Now we could do the same thing with a parabola oriented to the left or to the right. It wouldn't be a function, but it's still a parabola. And if it's oriented to the left or right, so this that we would have y squared equals 4px. And that is a situation where if 4p is greater than 0, it opens to the right. And if 4p is less than 0, it opens to the left. So we're looking at the 4p just represents the coefficient of the unsquared variable. And that's actually our next blank. 4p is the coefficient of the unsquared variable. So when we put it into standard form for graphing, we always want to make sure that the coefficient is not in front of the squared variable, but in front of the unsquared variable. The focus is p units from the vertex. The directrix is negative p units from the vertex. That's another important thing to remember. So when we see that coefficient 4p, if we divide that coefficient by 4, we know the distance from the vertex to the focus. The parabola always opens in the direction of which variable, squared or unsquared? Well, notice that to open, when it opens up or down, the x is squared, and when it opens right or left, the y is squared. So it opens in the direction of the unsquared variable. So I'm going to tell you a very touching and moving and perhaps emotional story that will help you to remember this little fact. Once upon a time, there were two sets of twins, the X twins and the Y twins, and they were very best friends, and they loved to go hiking together. And one time they were hiking in the woods, and one of the X twins went missing. They searched and searched and searched, but couldn't find that missing twin. And to this day, we still don't know whatever happened to one of the X twins. I mean, that's a tragic story. To this day, the remaining X twin continues to look for her missing twin. Now, where does she look? Well, of course, she would look in the X direction. So if the X twin is missing, she's going to look to the right, or she's going to look to the left to find her missing twin, because she's going to look in the X direction. Isn't that a sad story? So we want to look for the missing twin in the direction in which the twin is missing. Makes sense. I hope you didn't, if you need to get a Kleenex blow your nose right now, go right ahead. You can pause the video. Thanks. Okay, back to our next point. Oh, what a sad story. The next thing we want to say, if p is negative, the parabola opens in the negative direction. Negative for x would be left. Negative for y would be down. Okay. All right, having been armed with all these delightful and useful facts, now we are going to look at how to graph a parabola. So you're given a little equation, and the equation has one squared and one unsquared variable, so we know by that fact that it is a parabola. So that put it in standard form, notice, let's go up and look at our standard form. Standard form is x squared equals 4py, or y squared equals 4px. So notice standard form is with the squared variable by itself. So we're going to isolate the squared variable. So in this case, we would want to multiply both sides by -8. And so we would end up with y squared is equal to -8x. So that's step number 1. Step number 2, determine which direction it opens. Well, it opens in the direction of, oh, we're missing an x, so we got to look in the x direction for it. So it's either going to be right or left. And because 8 is negative, then it's going to be opening in the negative x direction. So negative x. So it's going to be opening to the left. Okay, so step number 3, find p. Well, p is found by dividing this coefficient by 4, because -8 is equal to 4p in the equation. Because remember, we have y squared is equal to 4px. So -8 has to be 4p, so -2 has to equal p, which means we're going to go in the negative direction from the vertex to get to the focus. Now, I've given you a particular equation. I'm going to go back and add one little comment to here. This is when the vertex is at the origin, at 0, 0. The equation will have an h and a k in it just like the parabola, or just like the ellipse and hyperbola did, if we are not at the origin. So we're at 0, 0. So plot that point. We go -2 to the left to find the focus. So there's our focus. There's our vertex. And the directrix is in the opposite direction from the focus. And since we're opening to the left, the directrix is going to be going vertically here, because the vertex is always sort of behind the parabola. It never cuts through the parabola. So there's my directrix. Okay, I've got all that. Use the Latus Rectum. Oh, snicker, snicker. That sounds like such a dirty word. Bad math word. But it really just means a straight line going through the focus that connects both sides of the parabola. So for example, here's my focus. This would be, I'm going to draw it out a little bit. This is the Latus Rectum, is this length, this little chord right here that goes perpendicular to the axis of symmetry, which is the x-axis here, and cuts across. An interesting fact about the Latus Rectum in a parabola is that it is always the same length as 4p. So it's 8 units long. So that means if it's 8 units long, I would go 4 from the vertex. I'm sorry, 4 from the focus. 1, 2, 3, 4. 4 units up, 4 units down. And those are 2 more points on the parabola. Now we can verify and then draw the curve. We can verify that those points are on there. Let's look at these points here. This is the point -2, 4, and -2, -4. We can also find points by just saying, okay, let's, if the focus is -2, that means that we're going to find a place where x is -2 in the equation. So if we have y squared is equal to -8 times -2, then that's y squared is equal to 16, which means y is equal to ±4. So when x is 2, y is ±4. So that's another way you can find those 2 points. But it's always true that this distance that I'm marking in red here is always going to be 4p, which is always the coefficient of the unsquared variable. All right, now let's take a look at graphing at some of our graphs here on the next page. So if we look here, we're going to do 2 types of problems. One is I give you the graph, you find the equation, and one's I give you the equation, you draw the graph. And we've done an example of 2 and 3. Hang on, sorry, I had just a wee bit of an interruption here. I think what I'm going to do is, no, I'll keep going for a little while, and then we'll go back. We may have to finish the application problem in a separate video. Find the equation for the graph below. So the first thing you do is think, is this an x squared equals 4py or a y squared equals 4px? Well, it opens in the y direction, so I must be looking for my missing y in this direction, looking for the missing y, so it has to be x squared equals 4py. Now I know the distance, I don't know the distance p because I don't have a focus drawn on here already. I'm going to erase my little arrow, it's kind of in the way. But I do know a point that's on the graph. And if I know that it goes through the point 4, 4, I can put in 4 for x and 4 for y and figure out what 4p has to be. So I'm going to put 4 squared is equal to 4p times 4. So we have 16 is equal to 4p times 4, actually, which is just means that p has to equal 1. So I'm just going to say 16p. So p is equal to 1, which means x squared is equal to 4y is my final equation. So that fits. It goes through 0, 0. It goes through 4, 4. That's the answer. The next one, we're asked to graph it. So we have, I want you to think, which direction does it open? It has a -4p and an unsquared variable of y. You're right, it opens down. Opens down. Unsquared variable, negative. So next thing is we find p. P is 4p is equal to negative 12. So p is equal to negative 12 over 4, which is negative 3. So it means I plot my vertex, which is at 0, 0 in this one. So 0, 0, I go down 3. I like making a little X for the vertex. That's kind of, or for the focus. That's kind of nice. And then I need to find another point on the parabola. And if y is negative 3, I could put in negative 3 for y and figure out what x would have to be. And then I could also, or I also can recall that the latus rectum is going to be equal to 12. It's the absolute value of 4p. So that means at the place where the graph, remember the graph's going to be kind of headed this direction, upside down. At the point where, at the place where y is equal to negative 3, the graph is 12 wide. So in other words, go 1, 2, 3, 4, 5, 6 in each direction from here. And that means that's how wide my parabola is. And I also need to draw my directrix, which is 1, 2, 3 in the other direction. There's the directrix. Now, I could have also plugged in a value for y into the equation and solve for x, or vice versa. If I plugged in, I like to see how wide it is at the focus. Sometimes that's helpful. Sometimes it's easier to plug in something larger or smaller, depending on the case. So plug in negative 3, I would get 36. I would have x squared is equal to 36. So x is equal to plus or minus 6. And that's what I got here, is this is the point 6, negative 3, and this is the point negative 6, negative 3. Okay, last one. You might want to turn it off and try this yourself and then turn it back on, or you can just do it along with me. And then I'll save the application problem for a separate video. We need to isolate the squared variable. So the first thing I'm going to do is say x is equal to 1/10 y squared. Then I'm going to multiply both sides by 10, and so I have 10x equals y squared, or y squared equals 10x, if that makes you feel better. So that means we're going to start at p here. Our vertex is at the origin. Which direction does it open? Positive x direction. Got positive x. And that plus x might be confusing to people, so I'll just draw the direction. 4p is equal to 10. We're going to get a p that's not a nice integer, but that's okay. You can handle it. So p is equal to actually 2.5. So we're going to go 2.5 for the focus. 4p is also the width. So the latus rectum length is also equal to 10, which means I'm going to go from the focus 1, 2, 3, 4, 5 up. 1, 2, 3, 4, 5 down because it's opening to the right, and draw my parabola. Vertex, or the directrix is 2.5 in the other direction, so there's my directrix. Okay, I'm going to stop now, and to get the very last part of the notes, you'll need to go to the parabola application problem.